Welcome back to Azure Terraformer. Today we have a mailbag episode. Yay! It's been a while since we've had one of these, so keep those questions coming. And if you have a problem or a doubt, please bring it up to me either on Twitter or on the comment section below. So anyways, this question comes from Kapil. Kapil says, "Hi Mark, I have one doubt. We need to access Cosmos DB from functions. Our function is in North region and Cosmos is in East region, both in different VNets in East and North region." So what does that kind of sound like to me? So it sounds like he has East region, North region, the Azure function is in North region, and Cosmos is in East region, both in different VNets in East and North region. And it sounds like the function app is also in its own VNet. Now, of course, with a function app, we are also going to have an app service plan in region. We talked about that on a previous video. So in North region, I'm assuming we're going to have an app service plan, we're going to have a function app, we're going to have a VNet, and he is trying to grant access from the function app to the Cosmos DB endpoint across region using outbound IPs to the Cosmos DB firewall. So basically, Cosmos DB can default to a public endpoint, which means you can send traffic over the public internet, authenticate. It's authenticated, it's encrypted using TLS. Transport layer encryption. There's access credentials that you present. They can either be like a shared key or an Azure Active Directory identity. So you could use a service principal to authenticate with. Sounds like that's what he's using. So the security mechanism that he's protecting the Cosmos DB endpoint is basically over on Cosmos DB. You know, he's saying, hey guys, I've got a whitelist here of IPs that are cool. And when we deploy a function app, it has a bunch of what are called outbound IPs. And he's somehow taking this collection, because it's not just one outbound IP, it's a collection of outbound IPs. And there's a whole bunch of them. It's kind of insane. So he's taking all of those outbound IPs and he's putting them into this whitelist, okay? And he's saying it's not working. Well, in this setup, what could be the problem? Well, we know that Cosmos DB is sitting inside of this VNet right here, right? So you might want to check out your your NSG, like what network security group, what NSG is attached to the subnet. So this guy's going to be in a subnet. And the subnet may be attached to an NSG. You might want to see, what rules you have on the NSG. Cosmos DB is going to be, communicating over HTTPS, so 443. So that should be pretty easy to spot if that's accessible. Another concern that I have is these outbound IPs, and having been somebody who's implemented outbound IPs and IP whitelisting as a security strategy, amongst others endpoint security strategies, I can say that this is pretty difficult to maintain because a couple of things. Number one, there's a whole bunch of these outbound IPs. I've kind of already gone over that. Number two, they change. And so if you're using Terraform to provision your Azure function, which you should, and Terraform is going to output you a list of outbound IPs. And then you can take that list of outbound IPs from that resource that was provisioned and pass that into your Cosmos DB account, which Terraform should be provisioning, and tell Cosmos DB, here's the list of IP addresses that I want to add to my whitelist. You might join that with another set of lists for different operators and things like that. Somebody other than the Azure function might need to, access that Cosmos DB endpoint. Who knows? Maybe not. But basically, that when Terraform does a Terraform apply, that's going to be a snapshot of those outbound IPs at that point in time. Those IPs may change. And so unless you're running Terraform apply on a regular basis and detecting what the actual current outbound IPs are, and then updating Cosmos DB whitelist with those outbound IPs, you could run into a problem like you're facing. Now, there are lots of them, so if you're adding all of them, you're going to be safe. I guess it isn't outside the stretch of the imagination that maybe you only picked one outbound IP address thinking that would cover you, but that's not a reliable way to do it. So you want to make sure you add all of them, which kind of compounds the problem that there's like a whole bunch of them, because you're not guaranteed which one at a time, and which one you use changes over time, which is why you have to add all outbound IPs. So that's what, like, without seeing your code, without seeing your deployment, Kapil, that's what I would recommend you look into. That being said, I would also suggest a couple of different options. Now, I don't know what Kapil's exact scenario is here, but there's other ways of handling this, right? So what are the pain points that we have? Well, one, we have a whole bunch of outbound IPs, right? So how do we fix that? This can be a problem, not necessarily if you control the integration, between your function app and whatever it's talking to completely. In this case, Kapil does. He owns the Cosmos DB. He owns the function app. He can manage those, and if he wants to deal with the burden of updating all those outbound IPs and adding them to the whitelist, that's on him. But Kapil might have like a third-party integration, and Kapil may not have control over their dictates, right? Maybe it's a customer, maybe it's a partner, and they're just like, give me an IP address. What are you going to do then? Here's 50 IP addresses, add them to your firewall. You're not going to make a lot of friends at that customer, and you might lose a customer, right? So what could we do? Well, we could replace the outbound, IP strategy here off the function, and rather than like using all of the outbound IPs that the Azure functions could use, Kapil's already attached his Azure function to a VNet. So this opens the door to the solution that I'm about to provide. On this VNet, we could add what's called a NAT gateway. And a NAT gateway is a special managed service that basically allows you to route all outbound internet traffic from that virtual network through the NAT gateway with, guess what? One outbound IP address, right? And I mean, it may be one, it may be two. It's a very small number. I'm pretty sure it's one. Or at the very least, you can configure it to one or to a specific prefix range. There's probably a multitude of different options. But the point is, you can control what the outbound IP address is, how many there are, as opposed to just like taking whatever Azure Functions gives you, which can be, as I've mentioned, problematic. So this outbound IP address that you get from the NAT gateway, guess what? That makes your life really easy. And if you make that outbound IP attached to like a PIP, public IP address that's static, that stays the same, you don't have to worry about like running Terraform apply and making sure that you keep that thing in sync. So then updating this whitelist over the Cosmos DB makes it super easy. It's still not going to work if your NSG blocks that sort of traffic. So you got to check your NSG. But it does make it a little bit more manageable. So that's option one. We'll just put that on there. Now, another option is you can use what Kapil is not using is, it appears to me, I don't know for sure, but the way he wrote this makes me think that he is using the public Cosmos DB endpoint, which is interesting because his Cosmos DB and his Azure function appears to be in each their own VNet, right? Which means they have their own private IP address, they're in their own VNet. Why don't we use private networking to connect them together? So in order to do that, this function app lives in a subnet within this VNet. And basically we can set up VNet peering between this VNet over here and this VNet over there, and we call that VNet peering. So this is what I'll call option 2, okay? So with VNet peering, what he's going to have to do is, which I presume he's already set up, which is why this is a little bit confusing, to attach Cosmos DB to a virtual network, you need to have basically like a DNS zone that has a record for your Cosmos DB, for the Cosmos DB endpoint, such that any private traffic that's trying to hit a Cosmos DB endpoint is going to get routed to the private endpoint as opposed to going out across the internet to hit that Cosmos DB. First of all, you should lock down the public endpoint on the Cosmos DB endpoint anyway. So in this situation, I'm going to say we're going to lock down the public access altogether. Don't let anybody come into the Cosmos DB through the public endpoint, and force traffic to go through the private VNet. And so in this situation, the function app its traffic is going to resolve to the virtual network that it's on, and through the VNet peering, it's gonna try and hit the endpoint of the Cosmos DB through that private network connection using the local DNS zone to resolve to the correct Cosmos DB endpoint. I am going to do a video showing you exactly how to do this upcoming, but this is kind of the idea behind it. So this is probably the most secure way of doing this, and I would highly recommend Kapil to do that. Frankly, Kapil is already set up with a lot, it sounds like everything that he needs to make this work, but he's still using IP filtering, whitelisting, and the public Cosmos DB endpoint to access the Cosmos DB account, which I don't think makes sense, considering it sounds like he's like 90% of the way there to get the private networking working. Last thing I'm going to say is, and this is more of a performance latency, kind of thing. The beautiful thing about Cosmos DB is you can very easily replicate across regions, which is an amazing thing. So I know according to this, and maybe I'm misreading this, maybe he's doing this already, but according to his note, his Cosmos DB is in East region, his function is in North region, and the function has to cross North region to East region in order to access that data. And so what he could very easily do, he doesn't even have to stand up another Azure function, in East region, right? Like he could just add another geo replication for the Cosmos DB account, and then once you've done that, in this setup, he's gonna have two endpoints. One is gonna be for East region, and one is gonna be for North region. This doesn't affect his network connectivity. He can still use the public endpoint and use IP filtering and use maybe the NAT gateway if he wants to make that more easy to manage, or he could use private networking and route the traffic to the local region to him, which in this case is North region. Now this will add some cost because you're replicating to that region, but it is going to improve the performance of your Azure function, because your Azure function is not going to have to wait to send the traffic across region, and you're not going to have cross-region egress. So that's something to think about. Also, what is that, option 3? Okay, option 4 is full active multi-region, where we set up a function app right here in East region. It has its own app service plan. This is the most costly of the options, of course. It also has its own VNet over here, which would also need to be peered to the VNet that the Cosmos DB is in. And then he would need to set up a global load balancer like Azure Front Door that's going to distribute traffic across the functions. So you're going to have traffic coming in there. The load balancer is going to distribute the traffic across the functions, and then each function will be configured with a different endpoint in its configuration, such that the function that's deployed in North region is going to hit the endpoint in North region, and the function deployed in East region is going to hit the endpoint in East region. And so this is a very common pattern with serverless on Azure, where you can basically take advantage of Cosmos DB's ability to replicate and take advantage of Azure Function's lightweight profile to deploy to those regions. Of course, I went over the different app service plan options. So if you use consumable plans, this is not going to be as big of a cost impact, but you will have performance considerations to take there. If you use a standard app service plan or a premium plan, there's going to be some cost, right? Premium Azure Functions, I think, is going to perform much better, and you can ratchet the cost down, but you will have some reserve capacity in both those regions, either with an EP1 or an EP2 or an EP3. So that's something to consider. But lots of different options for Capil to consider. I hope you guys enjoyed this video. If you did, smash that like button and consider subscribing to my channel. I'm trying to help you guys out, Terraform Azure. Anyways, that's it for me today. This is the Azure Terraformer, signing off.